so we're going to find the area of this figure. Now, the first thing I notice is that it's a composite figure because it's made up of two shapes. Remember, they're adjacent, they're right next to each other, and adjacent means you're going to add each area. So the first shape is a semicircle, and the second one is a rectangle. So I'm going to start off by typing in my formula for the area of a semicircle. Since a semicircle is half of a circle, we start with 1/2 pi r squared. And that's the area of my semicircle. Now I'm going to type in A equals LW because that's the area of my rectangle. Now, if I look at my area of a semicircle, I notice that the only thing my calculator does not understand is the R. So I'm going to have to give it the R. So let's come over here and find it. This whole side here is the diameter, which is the same as this side. So if my diameter is 6, I know that I have to cut that in half by dividing by 2 to give me a radius. And if you notice right there, my area for that semicircle is 14.1. So I'm going to come over here and I'm going to write it right above it so I don't forget what that was. 14.1. Now I'm going to move down a little bit and I'm going to find the area for my rectangle. The two letters that we don't know there, the two parts, are the length and the width. So I'm going to put L equals and W equals. This rectangle has both of those sides labeled for us, so that's not going to be nearly as complicated as finding that radius. So we're going to say the length is 6 and the width is 5. You can change those the other way, it does not matter, but either way, the area of your rectangle is 30, so I'm going to write that right here. Again, just to remind you, since these are adjacent side by side, to find the total area, we're going to add 14.1 plus 30. And that gives us a total area of 44.1. And that's going to be centimeters squared. Okay. I'm going to show you one more thing, except I'm going to go ahead and erase that for now. And I'm going to show you a trick. You do not have to use this, but if you decide you want to, it might save you some time. Since the area of a semicircle and the area of a rectangle have different numbers or different variables in them. See how the 1/2 pi r squared has an R and the LW are different letters? We can actually go ahead and we can put it all on one line. Now, if those letters are all the same, we can't do this. But since one is an R, one's an L, and one's a W, I can put the R as 6/2 because I had to cut the diameter in half. The L is 6 and the width of 5. And if I put it all on one line with a plus sign between the two formulas, it gives me 44.1. Just what we got by doing them separately and adding them together. Now we've got another one we're going to work on. So let's look at this one. It says find the area of the shaded region. Now these two figures, they're both rectangles, so we're going to have to do them separately. So A equals LW. That's going to be our very first one. L equals and W equals. There is a way to do this on one line as well, but you're going to have to come after school for me to teach you that. So let's start with the larger rectangle. Then this one that's on top of it, because they're stacked, is going to be subtracted. But let's start with the larger one. Length of 12, width of 10. So length of 12, width of 10 means that the area for the large rectangle, I'm going to write it right here, is 120 meters squared. But we need to cut out the smaller rectangle because it's stacked on top of the big one. And its length is 7 and its width is 2, which gives us 14. So this small one is 14. So to find the area of just the shaded region, we start with the area of the big figure, the big rectangle, which is 120, and we subtract or cut out the area of the small rectangle. And that gives us a total area for the shaded region is 106 meters squared. You can stop back, go back and watch that another couple of times to make sure you followed what we did. Okay? And we'll go on to the next video.